Question number 1. If x by 3 plus 1 comma y minus 2 by 3 equal to 5 by 3 comma 1 by 3, find the values of x and y. So here x by 3 plus 1 equal to 5 by 3. So here x plus 3 by 3 equal to 5 by 3. Then x plus 3 equal to 5 and x is equal to 5 minus 3, that is 2 here. Similarly, y minus 2 by 3 equal to 1 by 3. Y equal to 1 by 3 plus 2 by 3. Y is equal to 3 by 3, then that is equal to 1. So x is 2, y is 1. Question number 2. If the set A has 3 elements and the set B equal to 3, 4, 5, then find the number of elements in A cross B. So A elements are 3, B elements are 3. So A cross B will be 3 into 3. So that will be 9 here. Suppose A is having 3 elements 1, 2, 3. B is having 3 elements which is given, that is 3, 4, 5 here. Then A cross B when you are going to see, so that will be 1, 3, 1, 4, 1, 5. Similarly 2, 3, 2, 4, 2, 5. Similarly 3, 3, 3, 4, 3, 5. So total 9 elements. Question number 3. If G equal to 7, 8, H is having elements 5, 4, 2, find G cross H and H cross G. So here G cross H when you are going to see, the elements will be 7 and 5, next 7 and 4, next 7 and 2, next 8 and 5, next 8 and 4, next 8 and 2. Now coming to H cross G, H cross G 5, 7, 5, 8. Next 4, 7, next 4, 8. Next 2, 7, 2, 8. So this is G cross H and this is the H cross G elements. Question number 4. State whether each of the following statements are true or false. If the statement is false, rewrite the given statement correctly. First one, if P has M and N, Q has N and M, then P cross B, M, N and N, M. So it is a false statement. So because when you see P cross Q, we have sets, subsets. First M, N, next M, M, next N, N, next N, M. So total 4 sets, subsets are there. Second one, if A and B are non-empty sets, then A cross B is a non-empty set of ordered pairs x comma y such that x belongs to A and y belongs to B. So this is a true statement because A set is having x element, B set will have y element here. Third one, if A is 1 comma 2, B is 3 comma 4, then A cross B intersection null equal to null. So first B intersection null, you are going to say it is a null. Then A cross null will be null. So that will be null. So this statement is true here. Question number 5. If A set minus 1 comma 1, find A cross A. So here 3 sets, that is A, So A cross A we are going to see now. So first we are going to see minus 1 and minus 1. Next minus 1 1. Next minus 1 minus 1. Next minus 1 1. Next 1 minus 1. Next 1 1. Next 1 minus 1 minus 1. 1 minus 1 1. So total 8 subsets we are going to see here. A cross A. Sixth question, if A cross B having sets A comma x, A comma y, B comma x, B comma y, find A and B. So A, when you are going to say, so A elements will be in the first position, here B and here B. So 2 types of elements are there here. So A set will have A comma B here. Next B set, the second position, x y. So here 2 elements, that is x comma y. So A set will have elements A comma B, B set will have x comma y here. Question number 7. Let A is 1 comma 2, B 1 2 3 4, C 5 6 and D 5 6 7 8. Verify that A cross B intersection C is equal to A cross B intersection A cross C. So first we are going to see A cross B intersection C. So A element, when you are going to say, it is 1 and 2. Now B cross C. So B cross C, there are no elements common, so it is a null. So now A set and null, when you are going to see here, we are going to get a null here. A cross B. So A cross B means here we are going to see 1 comma 1, 1 comma 2, 1 comma 3, 1 comma 4. Next 2 comma 1, 2 comma 2, 2 comma 3, 2 comma 4. Now A cross C, when you are going to see, so that will be 1 comma 5, 1, 6, 2, 5, 2, 6. So here when you are going to see intersection, so there is no common here, so we get a null here. So we can say these two are equal. Next, A cross C and B cross D. So A cross C is a subset of B cross D. We have to check. So A cross C, so that will be 1, 5, 1, 6, 2, 5, 2, 6. So this is A cross C. Now B cross D. So B cross D when you are going to see, so that will be 1, 5, 1, 6, 1, 7, 1, 8. Next 2, 5, 2, 6, 2, 7, 2, 8. Next we can say 3, 5, 3, 6, 3, 7, 3, 8. Next 4, 5, 4, 6, 4, 7, 4, 8. So A cross B is a subset of B cross D. We have to check. So A cross B 1, 5. Here we can see the element. Here we can see the element 1, 6. 2, 5 we can see. 2, 6 we can see. So A cross B is a subset of B cross D. It is a true. Let A 1, 2, B 3, 4. Write A cross B. How many subsets will be have A cross B? List them. So here A cross B when you are going to see, we have 1, 3, 1, 4, 2, 3, 2, 4. This is A cross B. So how many subsets are there means that it will be 2 to the power of 4. That will be 2 into 2 into 2 into 2. So that will be 16 subsets will have. Question number 9. Let A and B be two sets such that A set 3 elements, B set 2 elements. If x, 1, y, 2, z, 1 are in A cross B, find A and B where x, y and z are distinct elements. So here when you are going to see A cross B when you are going to see, the first element will belong to A set, second element will belong to B set. So here we are going to see x, y, z as A set elements. So A set elements will have x, y, z here, and B set element will have second element 1, 2 and repeating 1. So B set will have here 1, 2 here. Question number 10. The Cartesian product A cross A has 9 elements, among which are found -1, 0, 0, 1. Find the set A and the remaining elements A cross A. So here 9 elements we are going to say as A cross A. Then set will have A set will have 3 elements here. 3 elements. So what are the 3 elements here? In the question they have given a position which is -1 and 0 and 0 and 1. So here first element will be -1, second element will be 0, then third element will be 1. So this will be a set elements here. And a cross a, so a cross a, when you are going to see, so then elements will be -1 -1, next here -1 -1 0, so -1 -1 -1 0, next -1 1, so -1 1 here, next 0 -1 0 -1, next 0 0, next 0 and 1, next 1 and -1 1 and -1, next 1 and 0, next 1 and 1 here. So these are the 9 elements. So in this we are going to see -1 and 0, 0 and -1, 0 and 1 here. So a set having elements -1 0 and 1 here.